Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. And in this course, we are going to learn the tools of statistical data analysis using the R software. So the first question comes here, what is an R software? And second question is that if you want to learn the R software, there are many things. Now the question is, what exactly do you require from the R software which is going to help you in this course? So this is my next objective. In the lecture today and in the next couple of lectures, I will try to give you a brief background about the tools which we are going to use in the R software in our lectures on data analysis. So this will help you in revising those topics and you are well prepared to use those tools in the further lectures. So this is my very simple objective. So with this objective, let us begin this lecture and try to understand what is required for you to learn from the R software. Okay, so in this lecture, we are just going to learn few basic things about the R software. The first question comes here, what is a R software? So we know that use of any software is desirable and moreover it is an essential part of any data analysis. Whenever we are trying to do any analysis based on the data, definitely we need the software so that we can make different types of computation. So softwares are used in all sciences, including the mathematics and statistics. And in statistics and in mathematics also, there are different popular software like as SPSS, SAS, Minitab, Stata, MATLAB, etc. So similar to them, we have one more software which is called here as R software. Right. So this R software is developed by the R development core team and this is freely available at this website www.r-project.org. And one good thing about the R software is that it is a free software. You don't have to pay anything for it. And one very important aspect which made this R software very popular is that it supports many free packages which help the data scientists and analysis. So what do you really mean by packages? Packages are the different types of programs which are required to do different types of computation and analysis. We will try to see in the further lectures that how we are going to use these packages. For example, if you want to do cluster analysis, then you need a package on cluster analysis. If you want to create a heat map, then you need a package to create a heat map. Or if you want to create different types of graphics, then there is another package, ggplot, which is needed. So this will help you. So now, if you try to understand what is an R, it is an environment for data manipulation, statistical computing, graphical display, and data analysis, just like any other usual good software. It has effective data handling and storage of output is possible. Simple as well as complicated calculations are possible. Different types of simple as well as complicated simulations are possible. And graphical display on a screen and hard copies are possible. The programming language is quite effective, which includes all possibilities just like any other good programming language. One good aspect of the programming language in R is that you can do your own programming and some programs have already been created which you can use directly. For example, if you want to compute the arithmetic mean, then yes, you can do your own programming also to compute the arithmetic mean like summation xi upon n, another number of observation and summation goes from 1 to n. You can do your own programming also, but if you don't want to do your own programming, then there is a built-in function like mean which you can simply call and use directly. So this is a very important and nice feature of this R software. So R has a statistical computing environment also, many types of statistical tools can be implemented directly, and they can be computed on the basis of given cutoff data. It has a computer language which is very convenient to use for statistical and graphical applications. And one good thing is this, that it's a free software, it's an open source software. It is not a black box. So if you really want to see what is really happening inside the package or inside the software by which the computations are being made, you can have a look, you can edit it, you can change it, and you can customize it according to your requirement also. And the built-in and contributed packages are available, and which users can also create their own packages. So what does this mean? That if you suppose want to do cluster analysis, so there are some packages which are given by the R software, and if somebody develops a new methodology for the cluster analysis, then they can also create their own packages and they can upload it, or they can get it uploaded on the website of the R software after some review. And that package will be available to everyone for using it in their own research. So it is also possible to contribute your own packages. Whatsoever be the command, they can be stored in a program, they can be executed, and the program here is called as a script file. Right. And this software is available for Windows platform, Unix, Linux, and Macintosh platforms also. The graphics can be exported in different ways, like a JPEG, PostScript, PDF format, and yeah, they can directly be copied and pasted in different softwares also. So if you really want to get this R software on a Windows, Linux, Mac, or any other platform, you can directly download them from the Comprehensive R Archive Network, which is shortly called as CRAN. C from comprehensive, R from R, A from archive, and N for network. And its website is www.r-project.org. So if you come to this site, actually, it will look like this actually. And here you can see here it is written download R, and then you can choose your preferred CRN mirror also. Mirror means, say, for example, because this R software is used by many people around the world, so in order to maintain the load, that is for the load balancing, the same software is uploaded on different websites in different institutions. So these are called as, say here, CRAN mirror, and you can download the software from your preferred website. Once you install the software, that's a very simple thing, that you download it and then just do clicks on the package file. Then it will install it, and by double clicking on the R icon, it will open a window like this one, which will look like actually this. This is called actually console. This is the terminology. So at the moment when I am recording this lecture, at this moment, this R version 4.5.1 is available, and after that you can see here they have given different types of instructions, right? And here if you try to see, there is a red greater than sign like this one. Here, this is the place where you type all your syntax and commands. This is called as command line, right? So before going into the further detail, let me try to show you here how it looks like, so that you can be confident that how it looks like. So if I come to the website here, you can see here, this is here the site. This is here rproject.org, and you can see here, this is here the area where you can say here download R, and if you say here download here R, then it will go to this different types of CRN errors. So you can see here it is from Argentina, Australia, Austria, Belgium. Different countries have uploaded the same software here, and you can download this software from any of this software. And after that, once you start the R software, it will look like actually here this. So this is here the R console, and this is here the command line where you type your command. For example, I can show you here. I can type here say here mean like this, or if I want to type on say here 2 plus 3. 2 plus 2 here, for example, if I enter, it will give me here answer 4, right? So this is how it actually works here, right? So now you are clear that whatever I'm trying to show you here, this is clearly visible on the software also. So when we are trying to work in this R console, then we try to type and execute the commands on the command line. So there are some external softwares like as RStudio, TinR, etc., which helps us in this programming, and they act as an interface between R and S. Right. So, and such softwares are actually more useful for the beginners, and it makes the coding and execution of the programs easier. Right. For example, this RStudio software is available at this website, say the posit.co. And similarly, there is another software here as a TinR. This is available on this website. Please remember one thing, I'm not trying to say advertise the use of RStudio, TinR or any other software. This is your choice whether you want to use this external software or you want to work directly on the R software. That is your decision. Right. So, and yeah, means I'm not going to explain you how to work on this RStudio. This is pretty simple and it is available on, say, different this online platforms, on this courses also in R software. Right. So anyway, so now if I try to tell you here that this CRN hosts approximately 22,800 contributed packages, and this number is constantly growing as the new packages are frequently added. So as I told you, the advantage of packages is that every package has a different role and they are useful in different types of jobs. So this number, if you try to see, this is continuously increasing, which indicates that more and more number of people are using R and they are trying to develop new packages for the users, right? And when we are talking about the R software, then the R software has two parts. One part is called the base R package, which is the software which you download from the R website. So this contains only some important and necessary which are commonly used libraries, right? Because you see, when we are trying to do the statistics analysis, then in all the analysis you don't need all the tools. So if you try to combine all the statistics tools in one package, then the size of the package will become too much. So that is why this R package has been created into two parts. One is the basic R package, which you have to download. After that, based on the requirement, you can download the required library or the required packages from the website for free. So all other libraries which are available, they are required for some advanced statistical work, which are downloaded and they are installed, and you have to do it according to your need and requirement. Right. So the next question comes, how do you install such libraries and packages in the R software? So in order to install the packages, the basic command here is install.packages, install.packages. So this is a function. Function means in simple language, this is a program which has already been written actually. You don't have to write a new program. So if you use this program or this function directly, then you can download the required package. For example, if I want to download the package ggplot2, ggplot2, 2 in numeral. This is the package which is quite good for creating nice graphics. So if I want to install it, because this is not available in the base package, the base package will also have some graphics, but if you want to have some special types of graphics, then you need this package. So if you want to install it, you have to simply write install.packages, and within the parentheses, within double quotes, you have to write ggplot2, and you will see that it will then install the ggplot2 package. Similarly, if you want to install, say, another package, graphics, then you have to write the same command, install.packages, and within parentheses, within double quotes, you have to write graphics, and it will install the package graphics. So let me try to show you how it actually works. So first, let me try to show you from the screenshot, and then I will show you from on the R console. So if you want to install the package, say this ggplot2, you have to just type this command on this command line. You can see here. After that, it will ask you secure CRAN mirrors. So that means you have to choose from where you want to download it. Here I would like to emphasize that all the mirrors, they have got the same package. Sometimes people say, okay, if you want to download, please try to download from the country which is closer to your place. It doesn't actually make any difference, because on the internet everything is the same. So you can choose any of the mirror whatever you like, and based on that something will happen. It may take couple of seconds, and after this type of message will come, and you can see here that this package ggplot2 successfully unpacked, etc., and the downloaded binary package are in this directory. So this is the location of my computer on which I am working. You may get at a different this address. It will not make any difference, but it's a very straightforward and simple process actually. And once you use it, once you install it, after that you have to use here a function library. This function will bring the package for using it. It is something like your university or a college has a library which has all the books. And if you want to use any book, you have to go to the library, you have to get it issued, and then you have to bring it to your places, and after that you have to give it back. So this library function is something like that you have to get the book issued. If the book is in library and it is not issued in your name, you cannot use it, or you cannot bring it to your home for using actually. So for example, if you want to use the ggplot function, then you have to type here library, library, inside the parenthesis ggplot2. And after that only you will be able to use the facilities or the commands of ggplot2 function. Similarly, if you want to use here the graphics package, you have to type here library graphics, and the graphics is within the parenthesis. So this will load the package, and then you will be able to use it. So before going into the detail, let me try to show you here that how it actually works. This is a very simple process, but I will just show you so that you become more confident. So you can see here, this is now here installed it. And you can see here it is now giving me some names of the CRN mirror. Suppose I choose here France. So this control will go to the France, and it will take this couple of seconds to download the package, and it will install it. Right. So you can see here that this package has been installed here, and now it is ready to use. So after that you can use this here function library, and then you can just use it. Right. So we move ahead. These are very simple thing. So as I told you that when you are trying to use here these packages, there are two types of packages. One is built-in, and the second is which are contributed. For example, this package here, MAS, MASS in all in capital letters. This is a package which is a built-in. Actually, this package is coming from the data resources which were available in the book Modern Applied Statistics Using S+, which was written by Wembley and Ripley. And yeah, actually this R was based on the S+ software, which was a similar software, but it was a paid software. So all the books and data, whatever was used in that book, that is now compiled in the library, in the package MAS, and we can use it by using the command library MAS. It will load the package. Similarly, if you want to use another this package here, MGCV, you can use here library MGCV. So this will help you in getting the kernelized additive models, right? And if you really want to know about that what is there inside any function, as I told you that that R is not a black box, right? So then you have here a help function, right? So if you want to see here that whatsoever are the content of the library ggplot2, you will get here this type of information. The package name is ggplot2, whatsoever is the title, the version, and then authors, etc., etc., etc. You will get lots of information, and after that you will see a list of all the functions and data set. Like here, this is a screenshot here, right? So you can see that that when I put the screenshots here, it becomes easier for you to understand. Right. Now, once you have done all the job, and all, I will say that whenever we are doing any job, we try to give any different names to the variables for analyzing the data. And R has one issue, that if you have suppose given earlier that x is equal to 20, and suppose if you want to use, and suppose you forget that you have given x equal to 20, and if you once again give x equal to 40, then this value will be overwritten. And R will not ask you or will not give you any warning that you want to replace this variable, etc., etc. So now there are two things, that you want to remove variable, or the second thing is this: whenever you are trying to get a new program, you would like to clean the window. Right. So that is why if you want to remove any variable from there, then the command here is rm. And if you simply write here rm parenthesis, and inside the parenthesis you have to write the names of the variable. For example, if there is only one variable, you can like rmx, or if you have three variables, say xyz, you can write down here rm xyz. So this will remove the variable. So the things will be in your control actually. And once you have completed your job, and if you want to quit R, then the command here is, say here, like as here q, and you simply say q and this parenthesis and this, and then you can quit the job. Right. So now that has come to an end to this lecture, and if you try to see, I have just given you very basic information about the R software to make you comfortable. I have given you some basic commands like install, library, etc., which we are going to use quite frequently. Right. My idea and my objective was simply to make you familiar that you don't need a lot of knowledge which is required to understand the topics in this course. And these are the minimum basic what we need. So if you are familiar with this thing, this will actually help, because later on, whenever I will be taking my lectures, then I will simply say, okay, please install this package. And then I believe, and I will assume that you know how to install a package, and the process will become quite fast actually. So you please try to revise these topics, have a look in the R software, and I will see you in the next lecture. Till then, goodbye.